Snowflakes are one of Mother Nature's most exquisite creations. Fragile snow crystals that dazzle us in an array of shapes and sizes. But there's a lot more to these intricate ice formations than meets the eye. Turns out that by looking a lot closer, snowflakes may also help us save lives. Here's correspondent Francesca Fiorentini's fascinating look at the secrets of snowflakes.
Beautiful and delicate, but also deadly.
It came out of nowhere when you're caught in an avalanche.
It's terrifying.
Most avalanche deaths are caused by suffocating under deep drifts or from the blunt force trauma inflicted by the onrush of snow. In fact, these giant masses of snowflakes can reach speeds of 80 miles per hour within about 5 seconds.
Imagine like being in a car crash and you're trying to just like hopefully save yourself.
And time runs against you. After an hour has passed, only 1 in 3 of those hit by an avalanche are found alive. The threat is so real that 150 people get killed by these juggernauts around the world every year.
In just a 2-week span, in February 2018, 7 people died from avalanches in one area of Washington state.
Three of them lost their lives on mountain passes just like this one.
3 people have been killed in 2 separate avalanches over the weekend. Rescuers found an adult near Stampede Pass in Kittitas County yesterday. These deadly incidents illustrate the extreme risk, not just in the backcountry, but even on the heavily used trails.
That's why I came here, to the shadow of Mount Rainier, to meet the daredevils that stop these deadly beasts before they strike.
So what's strange is that you all work for the Department of Transportation. And when I think of the DOT, I don't think of avalanches. I think of like a bus depot or...
Right, yeah. Because, you know, we have snowy mountain passes and avalanche hazard. We also have avalanche specialists who work highway avalanche forecasters.
State Route 140 takes us up the mountain on the Chinook Byway, a 92-mile hotspot for avalanches. And this road turns out to be one of the worst places an avalanche can hit.
With 30,000 vehicles a day and midweek we have 7,000 to 10,000 semis. So there's a tremendous amount of people moving across the highway, but also a lot of goods.
We finally make it to Chinook's actual mountain pass.
The snowiest mountain pass that WSDOT operates.
It's here where we find clues to the formation of avalanches.
We have today's snowfall, and then we can look at this upper layer. You know, that can pull off pretty easily. It's sitting on this nice, thin little crust.
Yes.
It's very fragile. Underneath that is this really loose, unconsolidated wet snow.
Yes.
As we move down, it gets a little more firm, and again, wetted snow underneath there. We can start to see some additional layers.
So the fact that there are different consistencies of snow layers actually make the conditions for an avalanche more likely.
More likely, exactly.
It's not long before John's team finds a classic avalanche trigger, a cornice, a mass of hardened snow hanging precariously above the road.
And you see that big overhanging piece of snow, that's the cornice that we're looking at.
Your concern is that it's going to fall on its own?
If it falls on its own, yeah. We hope to remove the cornice and make that area safe.
Meaning explode it away?
Exactly. So the crew, they've started setting up explosives in that area.
Would you hold that, Andy?
Sure.
Thank you, sir.
The demolition team has a tough task. They need to blow up the cornice without rattling the surrounding area and setting off an uncontrolled slide.
This is gonna be loud.
All right, ready for this?
I think so.
Okay. All right, guys. 3, 2, 1, fire. Nice.
Oh my gosh.
Yeah, so you can see the slide coming down now.
There it goes. Whoa. That was crazy. That moved really fast.
Yeah, that looked good.
Okay, copy that.
Their work is crucial for people's safety and for the economy. But what if there was a better way to prevent avalanches than hunting them down one by one? Well, in order to understand avalanches, you first have to understand snowflakes.
I'm here at Montana State University's Sub-Zero Lab, where researchers are at the forefront of discovering the science behind snowflakes.
This 27,000 square foot facility is one of the leading cold science research centers in the world.
Yeah, okay, no, I get it. I know why it's a Sub-Zero Lab. Okay, how cold is it in here right now?
Around -10 Celsius.
All the time.
All the time. Well, here in the center, you can actually see the crystals grow.
That is so cool.
So if you put your glove behind...
May I take a snowflake? Wow, it's beautiful.
I think that's totally doable. I mean, it's...
Lab director Dr. Ed Adams says there's a lot more to snowflakes than we think.
Snow it's kind of like a shapeshifter.
Snowflakes aren't frozen raindrops. They form when water vapor in clouds skips the liquid phase and crystallizes straight into a solid. There are at least 35 types of snowflakes. Some are shaped like needles, others are dotted with ice granules, and some are irregular crystals. Even though all of them fall at the same time, when it comes to forming avalanches, the prettiest one of them all can be the fastest to act out, the stellar dendrites.
The little stellar dendrites, those little star-shaped crystals.
Those are the beautiful sort of holiday car
Right,
star
exactly.
snowflakes.
Yeah, exactly. After they hit the ground, then they go through this metamorphism. They tend to change form.
Most snowflakes generally have 6 arms, formed by the accumulation of water molecules, 2 hydrogen atoms and 1 oxygen atom. But the stellar dendrites' arms are particularly unstable. They morph faster than other snowflakes, which can create a continuous hard layer of snow that can stretch across entire mountainsides. But sometimes the snowflakes stay separate, creating a weak, pillowy layer. If another hard layer is forged on top of this snowpack, the millions of snowflakes beneath them have set the stage for one of the most deadly forces on Earth.
We've got a strong layer, we've got a little weak layer, then we have a strong layer on top of it. That's your recipe for the avalanche.
By studying the mechanics of a snowpack and analyzing the snowflakes inside it, Dr. Adams' team is trying to improve avalanche prediction in order to save human lives.
Ultimately, what could your research lead to? Could you imagine something like a Google Maps of avalanches in the next 15, 20 years?
Yeah, certainly. We can get closer to that.
One day you might be able to browse an app that tells you where the snowflakes to avoid lie. But until then, avalanche hunters are going to keep trudging into the backcountry to try and understand and prevent the next disaster. So the next time you see snow falling from the sky, just remember that these tiny crystals are beautiful, but also dangerous.